A typical advanced physics question involving a projectile where a stone is dropped off a cliff of height h, and they don't give you the actual height. They just say that it's a letter or a variable represented by the lowercase letter h. And they're going to compare. They're going to drop a second stone at a cliff that's much higher, and they're saying that its height is capital H. And then the question is, if capital H, or the higher cliff, is twice as high as the lower one, how do those two stones compare in terms of times of flight, how long they're in the air, in other words, and how hard they're hitting the ground, how fast their impact speed is? Now, this can be a daunting question for a lot of students because there's no numbers in it. But when all else fails, and this is the method I want to start you on, when all else fails, you can make up some numbers and just compare a before and after. So, for example, we know how to solve these projectile questions. We set up our variables. So let's look at the first one where we're just saying it's little h, the lower cliff. When we solve projectiles, we write down all 5 variables. And in this case, we're looking for, well, 2 things. We're looking for final velocity and time of flight. Well, what do we know? We know that acceleration is always negative 9.8. And because you're dropping an object, we can assume in both scenarios that your initial velocity is 0. Now, I don't know v final, I don't know time, but d is given as this variable, h. Now remember, when we're dropping an object, we'd say that that d is a negative displacement because it's getting lower than it started. Let's just make up a number, and as long as we're consistent, and I'll show you what I mean by that, it should work. So let's say the original cliff is 100 meters high. Now, it's going to fall a displacement of negative 100 meters. So when I'm looking to figure out time, I want to pick an equation without v final in it. And we know how to do that. The equation without v final in it looks like this. Now, v initial, if you're dropping an object, is 0. 0 times anything is gone, so that part is gone. So we have a really simple formula that you've done a million times before. And all we got to do now is solve for time. Now, I'm going to solve for t algebraically. I mean, that's the whole point of this anyway. Let's see if we can get a value for t algebraically. So I multiply both sides by 2 and divide both sides by a. And that gives me 2d over a is equal to t squared. And then, of course, to get rid of the square, I have to square root both sides. Now, generally speaking, whenever you square root in physics, you should say plus or minus. But because it's time and we know we don't want a negative time, we'll just leave it as positive. So my time is root 2d over a. Now, let's figure out the time of flight when it falls a height lowercase h, which we've established is negative 100 meters. So all I do is I put in my numbers. 2 times negative 100, all divided by negative 9.8. I'm not going to put in the units there. And when I do that, I get 4.52 seconds. Now, as long as you're consistent, let's do the second cliff now. I'll do the second cliff in a different color. He still drops the stone, so v initial is still 0. We don't know what v final is. Acceleration still negative 9.8. We're looking for the time of flight. We want to compare times of flight in this case. So to do that, exactly the same equation. So for the second stone, I still have 1/2 at squared. And we now know when I solve it for t, nothing's changed. Like that. Put in your new height. Well, what's the question saying? The height h, capital H, is twice as high as what you said little h was. Well, if I set little h as 100 meters, we know that big H is now 200 meters. Now I have to put the negative in because it's falling. We're going to stick to our rules. And then I divide it by negative 9.8. And then I get my answer. And I get the time of flight for big H is 6.39 seconds. And if you look at that, that might be a little bit surprising because I know in a multiple choice test question, if I gave this question, there was a whole bunch of multiple choice answers, the most common answer, because people don't really know where to begin with it, is they'll just say, well, the height of the cliff doubles, so the time of flight doubles. And they'll pick, 2h or 2t, sorry. They'll say 2t is the final time, twice as big. But clearly that's not double. My original time was 4.52 and my final time was 6.39. Well, if you've got a multiple choice test question, you want to figure out how many times bigger th is than t little h, just divide them. What is that ratio? So if I go th divided by time of flight for the lower cliff, I get 6.39 divided by 4.52. Seconds cancel, and I get 1.41, and I'm going to give it a few decimals here, 414 times bigger. So in other words, the time of flight to fall a bigger distance is 1.414 times the time of flight for the smaller distance. Now, if you look at your answers, they never have this crazy looking decimal, but it's a square root. It's the square root of 2. So one of your answers will look like this. It's root 2th. So really, when all else fails, you make up some numbers. You've got your multiplier here, 1.414, and you figure out whatever's in front of this th here has to equal 1.414. It turns out to be root 2. Now, that's not the most elegant way to solve a question like this, but it's a fairly good start. Now, the second part of this, we want to figure out the impact speeds. So let's try that one now using the same method. Now, I'm just going to make some room here. We're going to do the exact same method and see how it goes. So now we're solving for the impact speed, and we're going to see how they compare. So let's begin again from scratch, and I'm going to set my height as -100 for lowercase h. And when I solve for v final, now let's assume we don't know t, pick an equation without t in it. So now I'm going to do this one. Now v initial is 0, so that's gone. And if I solve this algebraically for v final, I get root, there's that root again, sort of should give you a hint as to how our answer is going to look. Root 2 times your acceleration times your distance, or your displacement. So putting in my numbers, root 2 times -9.8 times -100. And if I crank that out on my calculator, I get 44.3. So V final, just before it hits the ground, and I guess it's on its way down, we might as well be consistent, is -44.3. Now let's look when we drop it twice as high. When I drop it twice as high, now we know the equation. Let's just cut to the chase. V final, they both start from rest, like that. So I just double my height. So 2 times -9.8 times -200. And when I crank that out, I get 62.6. Now it's on its way down, so again, I'll be consistent. 62.6 meters per second, negative because it's down. Don't forget, when you take a square root with velocities, it is plus or minus, and you have to establish which one you're going to use. So technically, I should have done that here as well, right? It is plus or minus. We're choosing the negative because it's on its way down. Now, the nature of the question is generally like because they didn't give you any numbers at the beginning, they just want to know how your final velocity compares at the larger drop compared to the final velocity at the smaller drop. And if you look at it, this is my final velocity when dropping the full capital H. And this is my final velocity when dropping only 100 meters, which we've said is the lowercase h. And I could again get how many times bigger it is. What is that factor? So if I go V final H all divided by the smaller one, V final lowercase h, and I get negative 62.6 divided by negative 44.3. I get this magic number again of 1.414, which we know is root 2. So in other words, my final velocity when falling the entire distance h is 1.414 times the final velocity when only falling lowercase h. So again, not the most elegant way to do it, but you can certainly kind of muscle your way through it. Now in the next video, I'm going to show you guys how to do this algebraically, which is much cleaner.